As we all familiar with generating random number using rand create. In this session, we will explore the relation between thread_rng and genRange function. First, let us create a Rust binary project. Here I include rand create and generate random number using the line rand : thread_rng dot genRange function. We are here to see the relation between thread_rng and genRange. Let us run the project. It prints random number on each run. Okay, now let us see the definition of thread_rng function. Here thread_rng function returns strut thread_rng. This is the definition of thread_rng strut. Just note that this is only available if feature std or std_rng is enabled. The function thread_rng is also available if feature std or std_rng is enabled. But in cargo.toml we are not enabled any feature. Then how thread_rng is available to use? Let us see rand create in docs.rs. and visit feature flags page. See, here the default feature includes std and std_rng. Through this default feature we get thread_rng function. Thread_rng function returns strut thread_rng. Let us go to docs page of thread_rng and search for genRange function in this page. Nothing found. Okay, let us search it in search bar. Yes, we got it. It's found as a function of RNG trait. Let me go within that. See, RNG is a trait which has genRange function. Okay, is there any relation between strut RNG and trait RNG? See, RNG is an extension trait which require RNG core. The implementer of RNG should implement RNG core also. Okay, let us search. Is there any relation between strut thread_rng and RNG core trait? Yes, RNG core is implemented by thread_rng. We got the clue. That is, RNG trait has genRange function. RNG core is a requisite of RNG trait. and thread-RNG is an implementer of RNG core. There is some circular relationship. We must go in depth. Okay, how thread-RNG get gen_range function? Here is the secret. RNG is implemented for type R with trait bound RNG core. That is, any valid Rust type which implements RNG core is implicitly implements RNG trait. So those all types receives all functions from extension trait RNG. As a summary, thread_RNG function returns strud thread_RNG, which implements trait RNG core, which is a requisite of trait RNG. Trait RNG has a function gen_range. From the outer box, there is no relationship between trait RNG and strut thread RNG. This is done by implementing trait RNG for a type R. Here R is just a valid type name. In the next session, we will see it in action. In this session, we will see the usage of extension trait and implement trait on type using the rand crate. First, I go to rand crate's GitHub repository and clone it to local. As a open source, we got rand crate's source. Through this, we can learn more. This is rand crate's project structure. Okay, in our project, for learning, we have to mark something. So I removed rand crate's dependency from cargo.toml. Now this line rand thread rng dot generate is not work. To make it work, first we need to mark library rand. For that I create lib.rs and within that I create a mark function thread rng and call it from main. Yes, we can call function thread_rng from lib.rs using our project name rand. Being an associated function, we can refer it using : the scope resolution operator. So rand : thread_rng is working now. Let's improve our mock. The thread_rng function returns strut thread_rng and this strut is placed in module thread under rngs module. So I create new directory rngs under src and within that create mod.rs. This is one type of module resolution and create thread.rs in same location. Within thread.rs, create strut thread rng with some sample fields. and include this thread module in RNGs by adding pub mod thread in mod.rs, and in lib.rs add RNGs as a public module. Add thread.rng function in thread.rs. And once again re-export thread.rng function from lib.rs so that we can get it from main. And now run the project and it just prints thread.rng strat. Okay, now add trait RNG core with a sample default function range. It is just a mock function. Then implement trait RNG core for thread RNG with the mock function. as RNG core is required to satisfy extension trait RNG. So now we create extension trait RNG with default function genRange, and this genRange function calls range function from RNG core trait. So up to this, RNG core is implemented for thread RNG, and trait RNG is an extension trait. It requires RNG core. Okay, let us check. Do we get function genRange in main? Still we didn't get. This is because still there is no relation between trait RNG and thread RNG. Before learning implementing trait on type, we will see how we can achieve this without implementing trait on type. For that, we have to implement trait RNG for thread RNG. Through this, instance of thread RNG will get functions from trait RNG. Now let us check if we got genRange in main. From the instance of thread range, yes, we got it. For that, we have to use rand : RNG in top. Okay, but without implement RNG for thread RNG, we can get function from RNG trait. This is achieved by implementing trait on type. This line implRNG for RNR with trait bounds RNG core and with or without sized. And another one situation, suppose if we have multiple struts that already implements RNG core in version 1, and in trait RNG is introduced in next version, and suppose if those struts instances need to access functions from trait RNG, means we can use implement trait on type. Here we have two struts, thread RNG, standard RNG. Both already implements RNG core, and as of this code, both struts also implements RNG trait. Now let us call genRange function from both instance. Yes, we can do it. Okay, now I comment RNG trait implementation and then check it. It shows error, that is method not found in thread.rng instance, and the IDE not shown error because I am not enable on the fly check. Now I enabled it. See, the IDE shows error that no method found. Okay, now let us implement trait on type using the code implRNG for R. That is, R is a valid Rust type which already implements RNG core as a trait bound. Run the project and check it. As it works, we have achieved. As a summary, we create binary project named rand. Even though it's a binary, we created library lib.rs within that and created module rngs in src folder. Under this rng module, we created thread module and propagated this thread module up to main by re-export it in lib.rs. In thread.rs, we created thread.rng function which returns strud thread.rng and re-exported this function in lib.rs. Thread.rng struts implements RNG core trait, which is a required trait of extension trait RNG. RNG is implemented for a type with trait bounds RNG core. That is, types which implements RNG core trait is also implicitly implemented for RNG trait also. This is same for standard RNG also. As a result, instance of both threads will get functions from a trait which is not implemented by itself but by the trait type implementation. We used Rust 1.64 for this demo. Thank you.